How do you accurately calculate pressure drop in complex pipe networks? Imagine trying to figure out how much energy is lost as water flows through a maze of pipes. That's what calculating pressure drop in complex pipe systems is all about. It's a key part of designing efficient systems for water supply, heating, or industrial processes. To do this right, you need to understand how fluid moves and what causes resistance along the way. The first step is to look at each part of the pipe network separately. Every pipe segment has some resistance because of friction between the fluid and the pipe wall. This friction causes a pressure drop, which means the pressure at the start of the pipe is higher than at the end. To find this pressure difference, engineers use the Darcy-Weisbach equation. It's a simple formula that relates pressure drop to the pipe length, diameter, fluid density, flow velocity, and a friction factor. The equation looks like this. The pressure drop equals the friction factor times the pipe length divided by the pipe diameter, all multiplied by the fluid density times the velocity squared, divided by 2. The tricky part is figuring out the friction factor, which depends on whether the flow is smooth and steady or turbulent and chaotic. For smooth, slow flow, the friction factor is just 64 divided by the Reynolds number, which measures the flow's speed relative to its viscosity. For faster, turbulent flow, you need to look up the friction factor in charts or calculate it using the Colebrook-White equation, which takes into account pipe roughness and flow conditions. Once you have the friction factor, you can calculate the pressure loss for each pipe segment. But pipes aren't the only thing causing pressure drops. Fittings like bends, valves, and expansions also add resistance. These are called minor losses. To find their effect, you multiply a loss coefficient by the dynamic pressure, which depends on the fluid's density and velocity. Summing all these minor losses gives you a total pressure drop from fittings. Elevation changes also matter. If the pipe goes uphill or downhill, gravity affects the pressure. The change in pressure due to elevation is the fluid density times gravity times the height difference. Going uphill reduces pressure, while downhill increases it. In a complex network, you do this for every segment and fitting. You calculate the pressure drop across each one, then add them all up. If there are pumps in the system, they add pressure to overcome these losses. The goal is to find the total pressure difference between 2 points, considering all these factors. To make this process easier, engineers often use specialized software. These tools can handle large, complicated systems, automatically calculating flow rates and pressure drops. They help ensure the system works efficiently, with the right pipe sizes and pump capacities. Knowing how to accurately calculate pressure drop keeps systems running smoothly, saves energy, and prevents problems down the line.